Hey, you're watching Tech Quiz, the digital lifestyle.
This is Tech Quiz. Woke up in the world made of cold and light. I see data flowing through the night. From my screen to the sky, signals fly. Be no reason, God wings, we never say goodbye. I'm building dreams in a laptop zone. Bytes and beats, that's how I'm known. I fix, I teach, I design my tone. Digital blood runs through.
Today we're going to look at the concepts of wireless communication. How data are being transferred wirelessly and the data involved. First, we begin with Bluetooth. Bluetooth is a short-range wireless technology that lets devices communicate with each other over a distance of 10 meters. Sometimes more. It uses radio wave or 2.4 GHz to send small package of data back and forth between devices. You have seen Bluetooth in action if you've ever paired a wireless earbud with your phone, connected a wireless game controller to a console, or transfer files between two smartphones. Bluetooth uses a process called pairing, which creates a secure one-to-one connection between devices. Once paired, they remember each other and can reconnect automatically in the future. Most modern Bluetooth use something called Bluetooth Low Energy or BLA. Bluetooth Low Energy consumes low or less power, making it ideal for smartwatches, fitness tracker, or wireless keyboard that runs on smart batteries. However, Bluetooth isn't meant for large data transfer, just short bursts of information like audio signals, input command, or sensor data. The downside, Bluetooth operates in same frequency range as Wi-Fi and microwaves. That is why sometimes your audio cracks when you are cooking while listening to a podcast or your special music. NFC stands for Near Field Communication. It's a type of wireless communication that only works over extremely short distance, typical for 40 cm or less. It is based on older RFID technology used and designed for fast, simple interaction between devices that are physically close. I've seen NFC if you have ever tapped your phone on payment terminal, scan a travel card on a subway gate, or exchange contact info with another phone just by facing them back to back. NFC doesn't require pairing. One device sends signal to the other device instantly, almost like whispering information into another device's ear. There are two types of NFC mode: active and passive. In active mode, both devices generate their own radio frequency feed. In passive mode, only one device actively transmits and the other just listens, like an NFC tag that opens a website or a Wi-Fi menu when tapped. Because it is so short range, NFC is actually secure more than other wireless mode. Someone trying to intercept an NFC transaction would have to be standing uncomfortably close, like next to you. That is what makes it useful for contactless payments, digital ID scan, and secure communication. Infrared. The IR infrared communication uses invisible light instead of radio waves. It is one of the most earliest form of wireless data transfer in consumer's device. You have seen the IR in your TV remote. When you press it, the button sends a beam of infrared light to the TV, which receives the signal and performs the command. Infrared requires the line of sight. That means two devices need to be pointed directly at each other with no obstacle in between. It is directional, like shining the flashlight, that makes the IR very limited in range, usually less than 5 meters, and vulnerable to sunlight or other bright light sources. In the early second generation, infrared was also used to transfer files between mobile phones, but it was painful, slow, and clunky. Today, IR is mostly used for remote controls, air conditioner panel, and other low bandwidth signal function devices. Advantages of IR is that it is cheap, it is very easy to implement, and it does not suffer from radio interference, but it is being replaced by more flexible options like Bluetooth and Wi-Fi most modern gadget uses. Next is the Zigbee. Zigbee is a wireless communication protocol designed specifically for smartphone devices with low power Internet of Things system. It is also optimized for sending small amount of data over a long period without draining the battery life. Zigbee operates in same 2.4 GHz band as Bluetooth but uses mesh network for secure network structure. In a ZigBee mesh network, each device like smart bulb, sensor, or plug can relay signal from other devices. So instead of each device needing a direct connection from the central hub or router, the signal can hop from one device to the next until it reaches its destination. This extends coverage or increase reliability for the entire network. For example, if your smart thermostat is too far from the main hub, the signal might bounce through a smart plug in the hallway and then a light switches in the kitchen to reach the thermostat. That is the mesh at work. ZigBee's strengths are its low power usage and scalability. You can have dozens of devices communicating efficiently without crowding your main Wi-Fi. ZigBee requires a dedicated hub like a smart home controller to manage the devices, and since a different manufacturer sometimes implements ZigBee slightly different, not every device works with every hub out of the box. Z-Wave. Z-Wave is similar to ZigBee but uses different frequency, typically 908 MHz in the US. This means it avoids interference with Wi-Fi or Bluetooth, which operate at 2.4 GHz. Like ZigBee, Z-Wave is designed for smart home automation and low bandwidth device communication. It also uses mesh network. Each device can pass long meshes to extend the signal range. Z-Wave has slightly longer range per device. It is up to 100 meters in open air and can support up to 332 devices in a single network. It is known for strong interruptibility. Z-Wave device must meet strict standard. So a Z-Wave motion sensor from one brand can work with a Z-Wave hub from another. That is not always true with ZigBee. However, Z-Wave networks are a bit slower than ZigBee and can be more expensive due to licensing fee. Still, many professional smart home systems rely on Z-Wave for stability and long-term performance. Z-Wave and ZigBee don't compete with Wi-Fi directly. Instead, they complement each other by handling background tasks like monitoring doors, adjusting light, and triggering alarm, while Wi-Fi deals with the video streaming and internet browsing. Wi-Fi. Wi-Fi is the most common wireless technology used to connect devices to the internet without physical cables. It transmits data using radio waves in two frequency bandwidths, 2.4 GHz and 5 GHz. The 2.4 GHz band offers wider coverage but slower speed. The 5 GHz band is faster but has a shorter range. It doesn't pass through walls easily. When you connect your phone or laptop to a Wi-Fi, joining a local wireless network typically managed by a router, that router acts as a traffic controller, directing data between your devices to your internet service provider. Most modern routers also support dual band or tri-band Wi-Fi. Wi-Fi standards are labeled by numbers like 8.0, 2.11 and 8.0, 2.11 AC and 8.0, 2.11 AX. The most recent version is called Wi-Fi 6.80 211X, which improves speed range and the ability to manage many devices at once. Perfect for busy home with smart TVs, game console, and smart home devices all connected. Most important thing, Wi-Fi is fast, but is also vulnerable if your network isn't secure with a strong password and encryption like WA3. Outsiders can connect to your network and potentially access your data. Li-Fi. Li-Fi stands for light fidelity. Unlike Wi-Fi, which uses radio waves, Li-Fi uses visible light to transmit data. It works by rapidly modulating the brightness of LED lights in a way that is invisible to the human eye. A Li-Fi enabled device picks these changes using a photo dictator and decode the data. Li-Fi is incredibly fast. In lab tests, it reaches speed over 200 GHz per second. It is faster than the most fiber optic internet connection, but it also has limitations. Since it uses light, it can't pass through walls or work in complete darkness. It also requires a direct line of sight between the transmitter, the light source, and the receiver of your device. Still, Li-Fi is promising for certain environments like hospital where radio waves might interfere with sensitive equipment, or on an airplane where it could reduce network interference. In homes and offices, Li-Fi could complement Wi-Fi in specific rooms where ultra-fast and secure communication is needed. Cellular network, 3G, 4G, 5G. Cellular network uses radio tower to provide wireless coverage across large geographic area. Your phone connects to the nearest cell tower, who then routes call, messages, and internet to and from your device. Each generation of mobile technology has improved speed, capacity, and latency. 3G was the first network fast enough for mobile internet browsing and video calling. 4G brought speed fast enough for HD streaming and mobile gaming. And high-speed download uses technology like the LTE, long-term evolution, to achieve this. 5G is the current generation, ultra-low latency, and the ability to connect more devices at once, uses a mix of low band, mid-band, and high-band frequency. High-band 5G, known as millimeter wave, can deliver a gigabyte per second, but only over short distances and with clear line of sight. 5G opens doors to applications like autonomous vehicle, remote surgery, and real-time augmented reality, and ultra-dense IoT network in smart cities. However, it also requires a dense infrastructure or small cell tower, especially in urban environments. Satellite internet. Satellite internet connects you to the web using satellites orbiting the Earth. It deals with the rural or remote area where fiber optic cables line don't reach. Traditional satellite system uses geostationary satellites positioned around 35 km above the Earth. This system have global coverage, but because the signal has traveled so far, they suffer high latency, usually over 600 milliseconds. This delay can be noticeable in online gaming or video call. Download speed are typically slower and upload speed even more slower. Data caps and higher costs are also common. A newer generation of satellites like Starlink by SpaceX uses low Earth orbit (LEO), which orbit around 500 to 2000 km. Because the signals travels a shorter distance, latency drops significantly, often below 50 milliseconds. LEO satellite constellation can provide high-speed internet to previously underserved area, but they require thousands of satellites working together and constant tracking to maintain coverage. UWB, ultra-wideband. Ultra-wideband is a short-range high-frequency wireless technology used for precise location tracking and fast data transmission over a short distance. It operates by sending a short pulse of radio energy across a wide frequency spectrum, typically several gigahertz wide. This makes it resistant to interference and capable of pinpointing accuracy. UWB isn't designed for internet access. Instead, it is used for spatial awareness. For example, Apple AirTag uses UWB to help iPhone precisely locate them, even showing directional arrow as you walk closer. Some high-end smart home devices uses UWB for presence dictation, like turning on the light when someone enters the room or unlocking a car door when the owner is nearby, because it can dictate movement with sub-centimeter accuracy and doesn't require pairing like Bluetooth. UWB is ideal for secure authentication, hand-free control, and indoor navigation. It is not widely used yet. As smartphone and wearable continue adopting UWB chip, you will see more devices using it for advanced motion and positioning in the future. Wireless charging. Wireless charging is a process called inductive charging to transfer power from a charging pad to a device without needing to physically connect the cable. It works using two coils, one inside the charger and other inside the device. When the charger coil is energized, it creates a magnetic field. The device coil picks up the field and converts it into electricity. This only works over a short distance, usually less than 10 millimeters, which is why your phone has to sit directly on the pad. The most common standard is the QI, pronounced as Qi, which is supported by most modern smartphones, wireless earbuds, and even electric toothbrushes. There are also resonance and radio frequency charging technology that allow for slightly more distance, but they are less common in consumer products. Wireless charging is convenient but generally slower and less efficient than plugging it directly. More heat are generated and positioning matters. If your phone isn't aligned properly, it might charge slow or not charge at all. Still, it is ideal for nightstand, desks or car mounts where you want to avoid plugging it directly or multiple times a day. The one on the screen worth a look if you like knowing what most people don't. Thank you for watching Tech Quiz. Today we talked about wireless communication. If you like what you've seen so far, kindly give us a like, a follow. For more information, scan the QR code you are seeing on your screen or visit our website at www.techquiz.name.ng for more details and tech tips. Until next time, this is Digital Lifestyle by Big Felix.
Tech Quiz, digital